back to my channel. Today we're going to work on the question min cost to connect all points. It's a medium level question, and the question states you're given an array points representing integer coordinates of some points on a 2D plane where points I equals xi, yi, and the cost of connecting 2 points is the Manhattan distance between them. So xi minus xj plus yi minus yj, where val denotes the absolute value of val. Return the minimum cost to make all points connected. All points are connected if there's exactly one path between any 2 points. Let's look at example 1. So this is the graph and these are all the points, and the output is 20. So basically we need to connect these points in a way that it's the minimal cost between them. And how do we know what cost it is? We just minus the x between 2 points, the absolute value of x between 2 points, plus the absolute value of y between 2 points to get the cost. Then at any point in time, if all points are connected in this graph, then we have gotten a path, like a minimal cost. So I'm thinking to solve this using union find. First, because union find, you can know you can check between 2 points if their absolute values, if their absolute root are equal, and if they are, it means they're already part of the same subset, and we don't need to union them together. And if they're not, we can union them together. But there's another key point: we need to find the minimum cost. So before we do the union and the union find, we have to sort the cost by the smallest to the largest, and then we can union them together. So let's start writing this. I'll first write my union find class. We're gonna write union find using path compression and union by rank. And each parent will equal itself in the very beginning, and then the rank will all equal 1 in the very beginning. So how do we know this find function is supposed to find the root? Finds the root, absolute root of a node. And how do we know we found the root? Basically, when the node's parent equals itself, so self node equals self dot parent node. When they equal, then we have found the root. We can just return the node, and otherwise we can use path compression to continuously and recursively look for the root. So something like self dot parent node equals self dot find self dot parent node. And then we can return self dot parent node. Then after we can write our union function, where we take in node 1 and node 2, and first we need to figure out the root of these two nodes. So root 1 equals self dot find node 1, and then root 2 equals self dot find node 2. And then if they don't equal, root 1 does not equal root 2, then it means they don't have the same absolute root, and we need to union them together. So basically now we have to do something called union by rank, and we have to figure out which rank is greater, and then we merge the smaller rank one to the greater rank one. So if self dot rank root 1 is greater than self dot rank root 2, then we just merge self dot parent root 2 equals root 1 out of self dot rank root 2 is greater than self dot rank root 1, and then we can merge the opposite root 1 into root 2, so root 2 is the absolute root. And then else if they're equal, it doesn't really matter which one we merge into the other. We're just going to default it to self.parent root 2 equals root 1. And then we have to increase the rank of root 1 here. Self.rank root 1 plus equals 1. And then here we finished our union function. Then lastly we can write a connective function to see if two nodes are connected, node 1 and node 2. And then if they are, we can return self.find node 1 equals self.find node 2. So we'll return true if these two absolute are equal and false otherwise. So we have our union find function, so we can start writing our code. We can create an instance of our union find, graph equals union find, and then we pass in the length of points, because how many points there are will be the end for our union find. Before we do that, we can do some base checks. So if not points or length of points equals 0, then we just return 0 as our total cost. And then I can do something like for I in range length of points, for j in range 1 to length of points. Actually, you can do length of points minus 1 to length of points, and then we can do y equals points I, and then first x, first y equals points I, and then we can do second x, second y equals points j, and then here we can do the cost, calculate the cost between them, so the cost will equal the absolute value of second x minus first x plus the absolute value of second y minus first y, and then I guess we can have a path. We can have a path here, a path list to record all the cost. So we can do something like path.append. We can append the cost, and then we can append the indices. So for I and then j, keep in mind we're not appending these coordinates because we just need the indices of index, like ID of the points that we're going to, from which point to which point and what cost. And then after we're done this, I need to sort the path. So now we have all the points and all the costs between them by doing this one, and we have all our cost and points stored in path, but we need to sort the cost here. So I can do something like path.sort, and then we can sort by key equals lambda, and then we can do x 0, so we sort by the first indices, so we will sort the cost from minimal to max, And then now that this is sorted, we can go through all the points in this graph, right, with the cost. So for cost I, j, and path, we can do something like if not graph dot find, graph dot connected. So basically this means connected ij. This means that if this function returns false, that if they don't belong to the same absolute root, then I can have a result here which equals 0 at first. I can do result plus equals the current cost because we want to connect them together, and then we can do a graph dot union I and j. And in the end, if we have everything connected, we just return the result here. Yeah, so it's been accepted. I think there's something wrong with my internet connection. Please let me know if you have any questions, and thank you so much for watching.